Hello science fans, physics paper 2, this is waves video number 3. So if you're revising waves, then this is video number 3, and we're going to talk about electromagnetic waves, and appropriately I'm using my laser pointer because of course laser is a form of light, and light is an electromagnetic wave. The things you need to know about electromagnetic waves is that they're all very similar and closely related, and light is one of them. They all travel at the same speed, which is the speed of light. The electromagnetic waves, or EM waves, come in a spectrum or list, and that starts at one end with radio waves and goes through microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays. The thing that you will notice from my notes here is that radio waves, they have a long wavelength and a low frequency, so that's only a small number of waves per second, and they don't transfer very much energy. Don't forget that waves transfer energy, that's what they do. At the other end of the scale, or spectrum, you've got gamma rays, which have a short wavelength and in fact a very high frequency, so you get very many waves per second, and they transmit or transfer a lot of energy, so high energy. The other waves sit in between, and if you look on the left hand side of the diagram, you'll see it shows that radio waves, the frequency increases as you go down the list or down the spectrum. So high frequency gamma rays, low frequency radio waves, and infrared are higher frequency than microwaves. The wavelength works the opposite way round, so radio waves have a long wavelength and it gets shorter as you go down the spectrum. So X-rays have shorter waves than, say, visible light because they're lower down the spectrum. You need to know a little bit about what each type of wave is used for by us humans. Well, radio waves, unsurprisingly, are used for television or TV and radio. They're used for Bluetooth. So when you connect your phone to a speaker, actually radio waves are transmitting the information. And the same with Wi-Fi. If you're connecting up to the Wi-Fi at Mackey's or at home or at school, then that Wi-Fi signal is carried by radio waves. Microwaves we're quite used to. They're actually used for satellite communications because they're not absorbed by the atmosphere, so they pass through the atmosphere. They're also used in mobile phones and of course for heating food, which we know all about. Infrared waves, well, they're also used for heating, but that's the sort of very bright red heaters that you get on some cookers on the hob. When you switch it on, you get this bright red light shining out and it gets hot really quickly, and that's infrared heating. They're also used for the security cameras and intruder alarm cameras, and when you're watching a cop show on TV, a true life cop show, and they're chasing the bad guys with a helicopter in the dark and you can see the bad guys in they look like they're bright white colours, then that's an infrared camera detecting the heat from the bodies of the bad guys. Visible light we know about. The thing you need to know is used in fibre optic cables for communication. So when broadband comes to your house in a cable, actually it comes in a fibre optic cable, which is a sort of bendy glass cable, and they use light to transmit the internet signals rather than electrical signals. So fibre optic communications is the use of visible light. Ultraviolet light, or UV, can be used for sterilising surgical instruments or dentist's instruments, things like that. And also they can be used for security marking. You can buy special ink that only shows up when you shine an ultraviolet light on it. Most importantly for Mr. Grinsell, it's also used for sunbed tanning. Ultraviolet is the type of light or electromagnetic wave that gives you a suntan. Interesting, I noticed those letters are in bright orange. Anyway, X-rays we know all about. That's used for medical imaging. And then gamma rays, well, they're used for medical purposes too. They're used to target tumour cells or cancer cells and kill them. It's also used for sterilising food because it will kill viruses or bacteria or other small forms of life that are on the surfaces of food, but it won't harm you at all. It doesn't damage the food. Okay, next thing we need to know about electromagnetic waves is some of the properties of electromagnetic waves. And we're going to talk about 3 of the 4. The 4th one we're going to go to in more detail in the next video. So here are the properties. Firstly, electromagnetic waves can be absorbed. You may have noticed that if it's a sunny day and you've got an object sat there, that object heats up. And it heats up because it's absorbing electromagnetic waves. In the case of a hot day, it's absorbing light and it's absorbing infrared waves. And what happens is when it absorbs them, those waves disappear into the object and the object heats up. The next thing that waves can do is they can be transmitted. And you can see my terrible drawing here of a window pane. Transmitted simply means that the wave passes through. So in this case, I've got probably a light wave passing through a window pane. So that's transmitted. The third thing that electromagnetic waves can do is be reflected. And we're very familiar with this from looking at ourselves in the mirror, where light waves are being reflected from the mirrored surface. So here we can see our light ray or light wave, and it's bouncing back off the mirrored surface. So it's not absorbed, it doesn't go into the mirror, and it's not transmitted, it doesn't pass through the mirror, but is in fact reflected back from the mirror. The fourth property is refraction. They can be refracted. I'm going to cover that in the next video because you need to know quite a bit about that. The final thing I want to talk about with regard to electromagnetic waves on this video is this box here in orange, which is the dangers of electromagnetic radiation. Here you can see I've done a diagram of a living cell with a gamma ray that's shining onto the living cell. One of three things will happen. It might just pass straight through, and in fact that's the most likely thing to happen and cause no harm. So the most likely thing is the gamma ray will be transmitted through the cell and cause no harm at all. But it might not be. It might be absorbed, and if it's absorbed, it might well kill the cell completely, and it won't just kill one cell, it'll kill lots of cells, and that will make you ill, cause all sorts of sickness, and can indeed kill you. The third thing that might happen, again, the gamma ray or the X-ray or ultraviolet, all three of those do this, might be absorbed by the cell. But this time it might be absorbed by the DNA within the cell, and that might change the DNA and cause mutations and change how the cell behaves. And that might make it grow, and you can see I've drawn this cell so it's starting to divide into two cells. And of course that can cause tumours, which in turn can cause cancer. It's worth noting as we finish this video that on our list of waves, of electromagnetic waves, the final three in the electromagnetic spectrum are known as ionizing radiation. All of these are forms of radiation. Radiation just means something that passes out or passes along, it radiates. But these three, ultraviolet, X-rays and gamma rays, are called ionizing. They're the three with the highest amount of energy, and they're called ionizing because they can affect the electrons in the atoms of cells and change them so that they become electrically charged and therefore reactive, and that's what causes these problems here that we're talking about. So they're known as ionizing radiation, ultraviolet, X-rays and gamma rays. Okay, end of video.